The reason why I would like to review, I always like to review a little bit before we go over the homework. But here I think it's very important because what we're going to be doing today is basically what we did yesterday with a little addition to it. Okay? What we learned yesterday, well, what we have learned so far about direct linear relations is direct linear relations have a graph that looks like that. Okay. This is the independent variable. This is the dependent variable. The title of the graph is always your dependent variable compared to your independent variable. You always put numbers and labels on the axes, the horizontal and vertical axis. So what makes this direct linear what makes it a direct linear relation? Well, I'll ask you. Listen carefully. Don't just answer what you think I'm asking. Listen to what I am asking. Why is this linear? I'm asking you why this is linear.
Straight line.
It's a straight line. It's a linear relation. Why is it a direct linear relation? Do you know, Aaliyah? Goes through the origin. Those are your two boxes that have to be checked. In order for it to be a direct linear relation, it has to be straight, and it has to be through the origin. And I don't have, well, I guess I could have written the word origin, but the origin is 0, 0. That's what makes it a direct linear relation. What we learned yesterday is that there's an equation that you can use to calculate y using x, and the equation is y is equal to m times x. This is the new thing we learned yesterday. Alexa, what's m? What does that mean? Slope. Which I don't know who came up with that decision. That let's call, what should we abbreviate the slope as? M. Okay. I don't know why it's m. We don't know why it's m. It doesn't matter. So now that you know what a direct linear relation is, if you ever want the equation, you simply find the slope and then you have the equation. So I'm not going to go through all of these. I think you pretty much finished them yesterday. But if we take a look at this, number 5, the following table shows the depth of water in a tank that is slowly being filled. So this is probably on page 25, I'm guessing. Okay. And it's filled at a constant rate. We talked about this yesterday because somebody had asked about this question. And the deal was if it's a constant rate, it's going to be a straight line. It fills regularly with the same rate. Like the water pressure is the same. It's not really the water's rushing out quickly and then 2 minutes later it's dribbling out and then it's quick again. It's coming out at a constant rate. And one more thing I want to review about linear. How can you, by looking at this data table, how can we look at those numbers and decide, well, this is a bad one. Can we look at these numbers and decide whether it's linear or not? Let me see if I can find a different table. And I'm going to ask you on this question, we'll get back to number 5 in a second. I'm going to ask you to ignore that last one. How can you tell that this is linear? Without reading the question, without even understanding what these things are, just knowing that this is x and this is y, my question is, how do we know it's linear? There's a trick we learned, and Alexa, you figured it out on the very first day. Do you remember what it was, Daniel?
side's going up by 1.
Okay, so let's just pause there for a second. X is going up by 1 each time. So X is going up by the same amount each time. Go on.
So the other side should be going up by the same amount.
Right,
Or
the other,
opposite rate.
by a same amount, right? Not necessarily by 1, right? So let's check this out. Figure out for me, Daniel, what you would add to 27 to get 36. And Elijah, can you figure out what you would add to 36 to get 45?
9.
9? I can't hear you. You also got 9. Perfect. So add 9, add 9. As long as when one of the variables goes up regularly by the same amount, the other one has to go up regularly by the same amount for you to determine it's linear from the table. So with this question, I said, how can we use the table to determine it's linear? And then I looked at the numbers and I realized we can't. Because look what's happening to x. Plus 3, plus 2, plus 5. It's all over the place. So the only way you could find out if this is linear is to graph it, but we know it's linear because it's a constant rate. So if the data were drawn on the graph, what would be the slope? Well, we can find the slope, and this is what we talked about yesterday. You don't need all of the points. If this is 2, 24, and this is, I'm going to pick 7, 84 today. Yesterday we did this with different numbers, and I know you've done this question, but sometimes you need to repeat to learn how to do it on your own, because I'm not going to be there with you when you write the exam. I mean, I'll be here, but you can't ask for help. How do we find the slope here? We're going to take y minus y over x minus x. So your slope would be 84 minus 24 over 7 minus 2. So everybody work out what we're going to get for the slope here. I'm thinking 12. And you might have to do this in pieces. You might have to, on your calculator, depending on your calculator, go 84 minus 24 equals and write down that number. And then 7 minus 2, which is 5, and then take whatever you got the first time divided by the 5. I'm just curious, so it works out to 12, and it's going to be centimeters per hour. I'm just curious because I know a lot of you have graphing calculators. How many of you, when you do this on your calculator, put a set of brackets and then 84 minus 24, and then divide by another set of brackets? I mean, I'm assuming many of you would just put 5 in because you know that 7 minus 2 is 5. But if you have a graphing calculator or a calculator with brackets, you can do that. So the slope would be 12 centimeters per hour. What's the equation? This is the new part. You know what the equation is? What's on our y-axis? Depth, let's call that d. Time, let's call it t. I don't know if you guys have noticed this. Absolutely. There's at the back of the room. And if you need to leave the room, no worries. I don't know if any of you have noticed this, but I like to use capital letters for the vertical and small for the horizontal. What's the equation? The depth equals 12 times the time. And my final question before we move on today, why? Where did I get this from? And I'll give you a hint. I'm not looking at the question anymore. I'm only looking at the fact that the slope that the slope is 12. Right? We got a slope here of 12. How am I getting this equation? I'm getting the equation because y equals the slope times x. So d equals the slope times t. All right, any questions at all from yesterday's homework? We're good? We're ready to move on? Okay. So we're looking on page 8 of your unit handout, please.